Can you guys see my screen?
Yes, sir.
All right. So let us start. Today we will continue from the previous class. That would be we stop at conditional probability, exercise 5, and I have given you the answers for exercise 4 and 5. Right. So today we will start from probability tree diagram. Hopefully everybody has this slide here, the one I share with you. Okay, see, people are still coming. You guys have to be ready at 8, not at 8:30. All right, probability tree diagram. This is a little disturbing. You guys have to join at 8:30, not 8 o'clock, not 8:30. Yeah? Okay. This is definition. The definition, of course, you guys can read by yourself. Now let us go for by one example here. You are off to soccer and love being a goalkeeper. Okay, you like to play football and you like to become a goalkeeper, but that depends who is the coach today. Okay, there are two coaches. One is Sam, another one is Alex. Coach Sam being probability, Coach Sam, the probability of being goalkeeper is 0.5. Coach Alex, the probability of being goalkeeper is 0.3. Now, if I want to write this in terms of conditional probability, it's going to be like this. If you have any problem in seeing my screen and my writings, please let me know. For example 1, if I want to write the information given in the example, with Coach Sam, the probability of being goalkeeper is 0.5. The probability of when Coach Sam is a coach, you become a goalkeeper, the probability is 0.5. When Coach Alex is a coach on that day, you become a goalkeeper, the probability of you becoming a goalkeeper is 0.3. Sam is coach more often, about 6 out of every 10 game. So the probability that Sam become a coach is 6 out of 10 game, and that would be this. So what is the probability you will be a goalkeeper today? So how to handle this kind of question? This question can be handled if you can draw a tree diagram. Let's say the probability of Sam become a coach 0.6. This is the probability of who? Alex become a coach. You are goalkeeper, you are not a goalkeeper. You are goalkeeper, you are not a goalkeeper. Sam become a coach. If you can see the screen, okay. This part is here, okay. That part is there. If Sam become a coach, you become a goalkeeper, will be here. Sam is coach, you become a goalkeeper, that would be 0.5. Alright. Now the second part, can you guess where is this? Alex become a coach and you become a goalkeeper. That would be here. Alex become a coach, you become a goalkeeper. That would be 0.3. Okay. Now, to fill up the other branches,
Doctor,
yeah,
someone asked if it can record and then upload in Facebook.
upload in Facebook.
Yeah, record.
It is recording now.
Oh, okay, thank you.
It is recording now. Later I will upload, don't worry.
Okay, thank you.
Now, if you see this, the tree diagram, if the branch comes from the same point, PS, the probability of Alex become a coach would be 0.4. How? The probability of branches, okay, the probability of branches coming from the same point if you plus, you should get 1. So this one is actually 1 minus 0.6. Where is the 0.6? The 0.6 is here. Okay, either any of the branch. If you can get any of the branch out of this the origin, okay, the origin is here. If you plus the probability from the same origin, you should get 1. So this one should be 0.4. And for this one, become Sam is a coach and you are not goalkeeper, that should be 0.5. And this one, you are not goalkeeper but Alex is the coach, that is 0.7. So you understand how I get these probabilities. Now the question is, what is the probability you will become a goalkeeper today? Look at this, goalkeeper and goalkeeper. To compute the probability you become a goalkeeper today, you have to focus on the end branch. Look at the G and G, goalkeeper and goalkeeper, and move from the origin, from the first branch. How are you going to attain here? Let's say you are standing here. You will go here and go here. Therefore, this probability is, if you go by branch, how to compute this probability? That would be 0.6 multiply 0.5. You will get 0.3. And how to go to this one? From the origin, like here, from here. This would be 0.4 and 0.3. This would be 0.12. Once you find the probability of becoming a goalkeeper from each branch, you have to plus now. So the answer is, probability of you become a goalkeeper is 0.3 plus 0.2, 0.12, and the answer is 0.42. That's how you find the probability by using tree diagram. This is being recorded, you don't need to worry. And I'm recording from not from Google Meet, I'm recording from some other tool. Later I will upload this as usual in the YouTube. Just give me some time to upload. We will have tutorial after that. That also will be uploaded in the YouTube. So don't worry if you cannot understand this. You can still see the video whenever you are free. Example, a graduate statistician A graduate statistics course has 7 male and 3 female students. The professor want to select 2 students at random to help her conduct a research project. What is the probability that the 2 students chosen are female? So the professor will select 2 students to conduct the research project. So let us look at the first student. The first student can be female or male. What is the probability of choosing a female? I suppose you guys know how to find the probability. Last class I taught you a little bit on finding the probability. Here female is 3 over 10, here 7 over 10. This is first student. Second student also can be female or male. Female or male. What is the probability of choosing a female on the second student? This is second student, this is first student. The probability of choosing a second female student would be 2 over 9 here, because you have chosen one student in the first. If you have chosen here female 1, see total how many female? Let me explain to you slowly. Female how much? 3. Male how much? 7. Now let's say you have the first student you have chosen female. Left is, now once you choose female, left is how much? Once you choose female, first student, left is 2 female student, male student remain unchanged. Total is now 9. So for you to choose the second female student, that would be 2 over 9. That's what I write here. Right? If the first student is female, what is the probability of choosing a male student? Now, this is first student. In the second student, once you choose the female, left is 2. Male is still 7. What is the probability of choosing the second student? Total is how much? 9. Female is how much? 7. 7 over 9. Hope you guys understand. Okay. If you choose the first student as a male, female still 3, male is now become 6 for the second student. Somebody please close your mic. Mute your mic, please. What is the probability of choosing second student as a female? Here, female is now, total is now again 9. Female is 3, so 3 over 9. So I write here 3 over 9. You also can write 1 over 3 if you simplify. And for the second student as a male, male is chosen. So male become now 6, female unchanged, total is 9. For me to choose a second student is 6 over 9. This is how we have to see the whole thing. Now once you complete the tree diagram, let us see what they want. What is the probability that the two students chosen are female? Two must be female. Where are the two female? First student female, second student also female. What is this probability? That would be 3 over 10 multiply 2 over 9. If you go along the branch, you multiply. If you jump from one branch to another branch, you plus. That is the idea. So if you do this, you will get 1 over 15. I think so. You can compute. Let me double check. Sometimes I do mistakes. Yeah, 1 over 15. So the probability both female is 1 over 15. That is the answer. This one, the professor choose one and immediately the professor choose another one. Okay, so the 10, the total, first total is 10, second total is 9. Okay, let us go to the another example.
Bro,
Yes?
nak tanya bro.
Yes.
Cuba kata sikit dia punya slide.
Okay.
Saya tanya yang macam 3/10 kurungan 2/9 tu nak kena tambah ke darab?
Darab.
Oh,
Sini darab.
okay.
Darab. Example 3. Now if you read this, the professor who teaches the course is suffering from the flu and is unavailable for the two classes. He cannot attend the two classes. The professor replacement will teach the next two classes. Somebody will come and replace the professor. Now his style is not like professor. The professor like to choose the student immediately, but this replacement guy like to choose the student one by one. His style to select one student at random and pick on him or her to answer question during that class. So what happened here is he will choose one student. Ask question, and then the student can sit back in the group, and then only he will choose another student. He choose first student, after the answer this student can sit back in the group, and he choose second student from here, which means the first student who answer the question can also be the second student. Okay, so the quantity, the total doesn't change, it always remains there. So if I want to do this in a tree diagram, just now different, just now professor different. What he did is he choose immediately two students, but the replacement is not immediate. He asked the first student the question, and the student can sit there again, and this the second student also can be the same student. Alright, so let us do the tree diagram. Three over 10, 7 over 10, since the quantity of student doesn't change, because the first student can sit back in the group, it doesn't change. it remains the same. The first student here, if she is a female, (3/10), male 7/10. The second student here, she is a female, the probability still remains the same because nobody is going out. So now what would be the probability that two students chosen are female? So the probability that both students are female is 9/100. That's how we have to answer. Let us do exercise 1 now. Please read the question. Two dice are thrown together. Use a tree diagram to find the probability that one number is even and another number is odd. Even, odd, so I put O here anyway. Even, odd, even, odd. So this is the first die, this is the second die. First, second. The probability is, so you know a die, isn't it? What is the number in a die?
6.
6. 1, 2, 3, 4, 5, 6. The probability, let me write it here, so I want to write the answer there. 1, 2, 3, 4, 5, 6. The probability of getting even number
3.
3, yeah. There are 1, 2, 3 even number. 3 out of total is 6. 1/2. The probability of getting odd number again.
1/2.
Yes, 1/2. So both are 1/2 and 1/2. So you can write the probability here. This is 1/2. Just simply write 1/2. If you feel comfortable want to write this, carry on. But I would like to write the probability only so that I understand much more clearer. You can see that total is always 1, 1, 1. Okay, just double check. Now what they want, use a tree diagram to find the probability that one number is even and another odd. If this is even, you go for odd. If another is odd, you go for even. So the branch goes like this. This would be and another branch goes like this. So as I told you, when you go by branch you multiply, when you jump from one branch to another branch you plus. So this will give you 1 plus 1 over 4, 1 over 4. This is basically 1 over 2. So the probability for you to get even and odd is actually 1 over 4 plus 1 over 4, 1 over 2. This is the answer for exercise 1. We will move on to exercise 2. If I am going quite fast, let me know so that I can slow down a bit. Exercise 2. Please read the thing. Questions? All right, let us do. Jack wake up late. Jack go to school. Jack this one go to school on time, this one go to school a bit late. This is late for school. I put a bar there. So also I can put a bar here. If I put a bar there, then it is a contrary from the previous one. So what is the probability that Jack wake up late? Okay, Jack wake up late on average 3 days in every 5 days. So probability of wake up late is 3 out of 5. This is 0.6. So 0.6 is here. And we fill up the tree by the information first. If Jack wake up late, here we are here, the probability he get late for school, he late for school is 9 over 10. 9 over 10 is 0.9. I write here. And you must remember that the notation for this is actually P. Jack wake up late, so he go to school late. This is the notation. Okay, try to get the notation if needed, otherwise no problem. If you can understand the tree diagram, that is okay, should be okay. It's just I want you guys to relate the conditional probability with the tree diagram. If Jack does not wake up late, which is here, the probability he is late for the school is here, 0.3. Okay, now we can fill up the other information in the tree diagram. If here 0.6, here should be 0.4. If here 0.3, here should be 0.7, and here 0.9, here should be 0.1. Alright, let us answer the question now. On what percentage of days does Jack get to school on time? On time, Jack get to school on time is this one, S and S. So we want this. So from here, this one, and from here, this one. And you have to plus this will give you so the answer is Jack goes to school on time is 0.28 plus 0.06 is the answer. The percentage would be, you have to times by 100, 34%. That is the answer for exercise 2. I give you some time for all of you. Can you guys try exercise 3 before I give you the answer? Just give a try first. How many of you there? 92? Okay. So 92 students are there. Try exercise 3 before I give you the answer. I'll be
Doctor,
Yeah.
your mic is mute.
Yeah, I know. I know my mic is mute, but I want you to guys to try first.
Oh, okay. Sorry.
I'm just writing the information. I know. It's okay. It's okay. Okay, so if you do this exercise, your tree diagram should be look like this. If all of you get this kind of tree diagram, that is good. Any problem getting this tree diagram? All of you get this tree diagram?
Yes, Doctor.
Yeah. So the question is, what is the probability that you choose shoe and socks the same color? The same color goes here. Black, black, brown, brown. So this one goes here. This one goes here.
Twelve over 65.
Yes. 12 over 65. This is also 12 over 65. You will plus 5 So the answer is probability of getting a shoe and socks same color is you should get this. Alright, try question 4. You guys try question 4, yeah?
Okay, sir.
Alright, if you draw a tree diagram for the exercise 4, you should get like this. If you notice, the total is reduced here 12, here 11. This is the same case on this exercise is almost similar to the professor. Remember the here, yeah, this example, the professor, which he choose immediately without asking the student to sit back in the group. Okay, so something like this. The fourth exercise, that's where the term here, without replacement, without putting back in the group. Okay, without replacement means once you selected and you are selecting from the remaining total, so the total being reduced by 1. This how I get all this probability in the same manner how I teach you just now in the professor thing. If you don't understand, later on you can ask me in the tutorial.
Sir, but they said 2 balls are drawn from the bag without replacement.
2 balls are drawn from the bag without replacement. Yeah, first this is the first ball, which means this is the first ball. 2 balls are drawn without replacement, so this is the first ball and this is the second ball. So once you select the first ball, you didn't put back, you're still holding it. That is called without replacement.
Okay, sir. Thank you, sir.
Okay. Alright, the question is, find the probability that balls are same color. So you go white and white. Branch. you should get this probability. It's 19 over 66. Those who have done can go for exercise 5. Exercise 5 is quite interesting and it's easy. Try to do first. Students who graduate from law school must still pass a bar exam before becoming a lawyer. So they need to pass the exam in order for them to become a lawyer. Suppose that in a particular jurisdiction, the pass rate for first time test takers, the passing if they sit for the exam, the chances for them to pass is 72%, which means if I write in probability, that would be 0.72. Candidate who fail the first exam, this is the first exam. This is first, this is second exam. The candidates who fail the first exam may take it again several months later. Of those who fail the first exam, we are here now. If they fail, 88% pass the second attempt, which means after the fail, if they take second time, 88% they pass, which means the probability for them to pass on the second attempt is 0.88. Now let us fill up the tree diagram. This one would be 0.28. This one would be 0.12. What the question wants? Find the probability that a randomly selected law graduate become a lawyer. So assume that the candidate cannot take the exam more than twice, so only 2 attempts. For him or her to become a lawyer, they need to pass the first attempt or the second attempt. What is the probability of becoming lawyer in the first attempt? 0.72. What is the probability of becoming a lawyer in the second attempt? What is the probability of becoming a lawyer? (0.72) plus 0.2464. Okay, this is the answer. Okay, I would like to give a break for you. You can take a 5 to 10 minutes break and then we will come back again. Do the last part in our probability. Alright, so take a break. I will see you around 9:35, something like that. Okay, let us continue. So the next section would be the last section, Bayes' theorem. Before I explain to you what is Bayes' theorem, to make your life more convenient and easy, let us look at this example. Let us try to solve certain question, and then I will come back to you what is Bayes' theorem. Maybe not this class, maybe next class. Okay, let us try to solve certain question which is quite different from the other question we have done so far. Okay, please read the question, the example. In a certain plan, 3 machines B1, B2, B3 make a product whereby B1 take part 30 percentage, B2 take part 45 percentage, B3 take part 25 percentage in producing a product. It is known that from the past experience that the product made by all these 3 machines do have some defective. The percentage is 2, 3 and 2 respectively. Now if a finished product is selected randomly, what is the probability that it is defective? First of all, let us write the information from the question in a mathematical statement. The probability of B1, which means B1's part on producing the product, is 0.3. Okay, 30 percentage, I write it as 0.30, so it's 0.3. This is 0.25. It is known from the past experience that the defective rate is 2, 3 and 2. So if a product is made by B1, then the defective, by the way, I have given here, I have given the notation here, A is the defective. If the product is made by B1, the rate of defective is 2 percentage, which is 0.02. If B2 3 percentage, 0.03. B3 2 percentage, 2.02. Question is, what is the probability that it is defective? What is PA. Now let us do this, at least one question. Okay, if you look at the slide, I don't know whether still remember or not, the marginal probability, okay, is actually, I told you last time, if you go back to the previous first slide here, this slide, still remember? Maybe you can see this one also. If I want PA1, I need to plus all the probabilities associated with A1. So A1, B1, A1, B2. If there's a B3, then I need to plus with that also for me to get A1. Same goes for this one. If I want PA, what I need to do, I need to plus all the probability which is related to A. In this case, B1, B2 and B3. Okay, this is the notation for AND. Here I have written the word, here I have used the notation. Now, remember how, you see, the information here, we don't have this one. Do you see this probability here? A and B1 here? Nothing. The information given to us is probability of B1, B2 and B3 and the conditional probability. So we need to get this probability from the given information. So how am I going to write this? Remember what is conditional probability? PA B1 is actually equal to, let me write it so that I can write everything. Now if I want this, because I need this one, isn't it? If I want this, what I should do? Cross multiply. So my PA is equal to this one. If I want to find A and B1, so what I need to do now, place A1, what is B1, 0. So the answer is .06. Okay, that's how we get A and B1. So if you look at the note, this A and B1, you can write it like this. Okay, write it like this. How I get this, I have explained here. Okay, this. So each of them you can write, and each of them you can find the value and then replace it, and you will get probability of defective. Okay, hope you guys understand this and get to solve this kind of questions. Now next question. If a product were chosen randomly and found to be defective, what is the probability that it was made by B3? The question is, in the previous one, if you notice the previous one, in the conditional probability, they say B1 happened first, and then they're asking for what is the probability of A. B2 happened first, and then they ask what is the probability of A. And B3 happened first, and then they ask what is the probability A is happening. Now the question is the other way around. The question is, if a product were chosen randomly and found to be defective first, which means this one comes first, what is the probability that it was made by B3? Okay, so how to find this? This is exactly B3 and A. This part here, I can write it as A and B3. Okay, so this one I can write like this, and from our information we do have this information, A, B3, and you can find the rest. Okay, so you can see here B3, this is the idea, and how I get 0.05 from here, this one 0.05, remember 0.05, A, B3 is what, 0.005, not 0.05, 0.005. And what was our PA just now? 0.0245, and the answer should be 1049. Okay, you can read this formula by yourself instead of me explaining. You try to read and answer the questions, try to understand. Now look at example 2. try to read first. So first of all, you can see that they have given you the probability of each plant for the product, and also the probability of defect of each plant. Question is, which plant most likely use that's responsible? If a random product was observed and found to be defective, which plant was most likely used and responsible? First of all, write the information. P1 is 30%, 0.3. P2 is 20%, 0.2. .5, and then if a product made by P1, the defect rate is 0.01. If the product made by P2, the defect rate is 0.03. P3, the defect rate is 0.02. In the slide I have given this one. Okay, now we are going to find, if we are going to find this, if a product is defective, what is the probability that it is made by P1? If a product is, sorry, not defective, is D here. If a product is defective, what is the probability that that product is done by P2? If a product is defective, what is the probability it is done by P3? Okay, let us do the number 1. P1D. What is the formula of conditional probability? P1 D1. This part I can write it as dP and this is actually dP 1 PD. Okay, now we're going to find how to find this, and how to find this. Still remember how we found our PA here? The PA, where is PA? You see the PA here? What I told you, if you want to find PA, plus all the probability associated with A. So if you want to find PD, what you need to do? Plus all the probability associated with PD. Here the D is associated with P1, P2, P3, all the associated probability with D. Now remember how we find this? Zero point 0.01 and P1 is 0.03. This one should get, you should get 0.03. So like that you are able to get the rest of it. If you compute each and every thing, you will get this one. This one you will get 0.02, this one you will get okay. So PD is basically 0.03 plus you will get 19. We need to find this one, D and P1. D and P1 actually we already computed. The answer is 0.3. We have computed here 0.003. Yeah? So PD1 is actually 0.003, 0.019 and 0.158. This is only for this one. If you do the same method for P2D and P3D, okay, remember we need to find this one also, P2D and P3D. You should get this answer. You try on your own. You should get this answer. I have given the slide also. Okay, Now if we find this, you will have three. Remember, our aim is to find three probability. Our aim is to find this one, P1D, P2D, P3D. That is our aim. So we have found here this one, and this one. What is the question? Go back to the question. If a random product was observed and found to be defective. If you choose a random product, which plan was most likely used and thus responsible? Which probability is higher? This one, isn't it? Therefore, P3, the probability of P3 and D is higher, which means if you choose a defective product, most probably that defective product is made by plan P3. Okay. So the conditional probability of defect given in 3 is the largest. So this is the largest. Thus the defective random is most likely from P3, plan 3. So the answer is plan 3. Alright. Most probably you guys are tired. And there are more examples. We will continue this in the next class. Next class we will continue this. We stop here. And next at 11 I have tutorial. I will see you all of those who are in the tutorial at 11. So that's all for today. Thank you for attending the class. I'll see you guys next week. Same time, same day. Please be on time. At 8 means you must be get ready at 8:55 at least 10 minutes or 5 minutes earlier, so that there's no interruption during the classes. With that, thank you very much. I'll see you guys next week. Bye.
Thank you.
Yep.
Thank you, Doctor. Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
Thank you, Doctor.
All right.
Thank you, Doctor.